If you remember from our first video, we ran an application contact form built with HTML and JavaScript. We're going to discuss that form now. First, we will look at the labels and text boxes created with HTML. You'll notice I've opened the document with my editor. To save time, I'm going to explain the form without typing. You can follow along by downloading the entire document in the description link below, or you can type it if you choose to do so. I recommend typing code because it allows you to involve yourself in the code. Typing also produces errors. By working through them, you'll become a better programmer. First, notice that our form contains both HTML and JavaScript. I'm going to focus on the HTML first, so I'll collapse the JavaScript code found in the script tags. The first line of code contains the HTML preamble followed by the HTML tag, which contains a head and body section. The head element includes the usual contents with a meta tag that identifies the character set of our page and the title of our page. In the body, after the script tag, we have a heading 1 element that displays at the top of the document. Then we find the form. All of the HTML code that appears between the opening and closing form tags is responsible for giving us the user interface where a visitor can provide us with information. Notice the form element contains an ID attribute and the value assigned to the form is contact form. Remember that spelling is important. Contact form is all one word with a capital F in the word form. Next, notice that the form contains 3 sets of labels and text boxes for capturing the first name, last name, and email address. You'll notice the text box contains a variety of attributes, but let's focus on the attribute called name in each of these elements. When we submit HTML forms to a server, the name attribute is critical for passing the data to the back end of our application. We'll see this later in the video when we dissect the JavaScript code. For now, I want you to notice that I've abbreviated the first name, F name, the last name, L name, and the email address is not abbreviated. Lastly, with regard to the form, you will notice that we have a submit button for submitting the form to the server. If this form is somewhat confusing, I plan on creating videos on this topic in the near future. Please check the description below for a more detailed explanation in a few weeks. Now, let's move to our JavaScript. The first line of code ensures that the JavaScript enclosed in the braces will not run until all of the elements in the HTML document are loaded. Notice we reference the contact form ID near the top of our page, but we don't define contact form until we get to the bottom of the page. Without an onload statement, our JavaScript would fail because the contact form is unidentified until the form is loaded. The first line of code ensures that the JavaScript code will wait until the document and all of its elements, including the form, are completely loaded in the browser. Inside of the onload event handler, we are adding an event listener on our contact form, which we've identified with the ID attribute. This listener is set to trigger when the submit event of the contact form occurs. This means that when the submit button inside of the form is selected, the code defined in this event will run. This, my friends, is where the magic happens. Now, the first line of the submit event is to prevent the browser from submitting a form like it normally does. Remember that we want to run custom code. Without this line, the browser will attempt to submit the form using its default behaviors. We want to stop default behaviors from occurring, so we need to interrupt them, and we do this with the prevent default method. The next line of code collects data from all form fields that have a name attribute and stores them as a form data object. Remember earlier in the video, I mentioned the importance of the name attribute. This is where we will be needing it. The form fields with the name attribute and their values will be stored in a form data object. The form data object provides us with an easy, single line of code to collect our form fields and their values. Unfortunately, the form data object isn't usable for our purposes in AWS. We need to convert the form data object into JavaScript object notation, or JSON for short. In order to get the data into JSON formatted text, we will use a two-step process. First, we will convert the form data object into a plain JavaScript object. This conversion is done with the line const data equals object dot from entries and in parentheses form data dot entries parentheses. Now with the data stored as a JavaScript object, we perform the second step, which is to convert the JavaScript object to a JSON text string. The second conversion is done with the code const JSON payload equals JSON.stringify parentheses data closing parentheses. As an example, if we have the following form data, the name attributes for the text boxes are fname, lname, and email, and the values are I'm a dev and I'm a dev at professorquinn.com respectively. So the string stored in the JSON payload constant when running the code would look like this. fname, I'm a, comma, lname, dev, comma, email, I'm a dev at professorquinn.com. Notice that the double quotes surround each one of the strings, and the entire string is enclosed in braces. Next, we find a console log statement so we can output the JSON payload value. This is followed by a line of code that assigns a value to our API gateway. This constant currently stores a placeholder. After building the rest of our application in video 3, we will be able to update this placeholder with an actual API gateway invoke URL. Lastly, we have a fetch method. This will post, or submit if you prefer, the value stored in the JSON payload to the API gateway. You can see the content type has a value of application/JSON to identify that that's the type of data that we are sending, which is JSON formatted text. We will talk more about post and CORS and their relevance in video 3. The remaining code deals with handling return messages from the server. First, we have code that executes writing output to the console, an alert, and writing to the document when the form data is successfully sent to the server. Then we have code that catches errors. Notice if an error occurs, output displays to the console and an alert box. To finish setting up the front end, we will deploy our application to AWS Amplify. The first step will be to name our application index.html. I've already saved this document, but this is as simple as going to the File menu, choosing Save As, picking a directory, and giving the file the name index.html. Every website should have a landing page, and since we only have one page in our site, we will need to name our page index.html. Now, with our page named appropriately, the next step will be to create a zip file from our index page. We can do this on a computer with the Windows operating system by navigating to the folder where the page is stored. We right-click on the index file and choose Compress to and Zip File. To keep the name index for our zip file, I'll press Enter on the keyboard. Again, don't change this name. Okay, great. Now our application is ready for deployment. Let's log into AWS and open Amplify. Now I can get there from my recently visited links, but if you didn't see that, what you could do is you could click in the search box and type Amplify. Next, we can click on AWS Amplify. And we're there. You'll notice that I have the completed application here, so let's create a new application for our unfinished form. I'll start by clicking the Create New App button, and next we'll choose Deploy Without Git, which gives us the option of uploading a zip file, which is exactly what we want to do. We can click Next, and we can name our application. Let's call the application Contact Form Unfinished. Following our naming convention, we will omit spaces and use all lowercase letters except for the first letter of each word after the first word. We can leave the branch name set to staging and check that drag and drop is selected for our method. Realize you can either drag and drop the zip file or navigate through the file system to find the file that you wish to deploy. I'll open the Exploring window and drag and drop the file. Again, we want to make sure that we get the zipped file, not the HTML file. Notice the uploaded checkmark appears, so we can now save and deploy. The next screen appears, and we can scroll down, if necessary, to see that our application is in the deploying stage. Be sure to wait if it still shows deploying. When it's done, in the staging area, it will say deployed, as we see here. Once you get to this point, congratulations. Give yourself a pat on the back. Your application has now been deployed. We can either click the link at the bottom of the screen or in the top right of our application to load our deployed URL. To test out the application, in the first name box, I'll type Yura. In the last name box, I'll type dev. And in the email, I'll type yuradev@professorquinn.com. Next, I'll click the Submit button, and you'll notice that it says the form submission failed. And that's okay, because if you think about it, we haven't set up the backend yet. However, when I click the OK button here, and I look at the console, we have the JSON key value pairs for the first name, last name, and email. This indicates that our front end is probably working correctly up to this point. We just need to build the rest of the application, which we'll do in the next video.